right, so students always ask, why do we have to use these scores? The big key, which you're going to see when you get reading the Z table, is we only want one table, right? So there's only one place we want to look. Another huge reason, what if we want to compare, they always say things like apples to oranges, or here's an example where somebody has taken two tests and we actually want to compare to see which test they did better based off of the information we're given. So this first test, this is going to be a sample mean. I'm trying to write and it's not writing. There we go. So X bar, I mean, mu's okay. It's just not the population. And so this sample, they say the sample mean of the psychology test was a 91. And this sample mean was a 57. Okay, we're just assuming these are out of 100, right? All right, and so based off of this, it says on the psychology test, this one made an 81. And on the economics test, this one made a 30. The standard deviation is 12 for the psychology and 9 for the economics test. So what we want to do based off of this data, we want to figure out which was the better score, right? So what we can do is we can standardize both of these with z-scores. So remember, a z-score is standardizing your mean to 0, and then it's seeing how many standard deviations you are away from the mean. Both of these are below the mean, so we should get a negative z-score. And you do this by taking your data value of interest, which is 81. You subtract the mean, which is 91. And then you divide by the standard deviation. So we do the same thing over here. The mean is, I'm like, what did I write there? That's supposed to be X bar 57. The mean is 57 minus, I'm sorry, went backwards there. Let's cross that out. Don't have my eraser. The value of interest is 30. The mean is 57, and then divide by 9. So if I put both of these in a calculator, this first one I get negative 0.83. This one I get negative 3. So what this is saying is, if this is standardized, this is negative 0.83 standard deviations from the mean. If you remember with the empirical rule, if we're within one standard deviation, that's 68% of the data. So this person's not that far from the mean, or this test is way below the mean. Okay, so if you even think about a number line, negative 3 is certainly way, way, way below on the number line. So then it asks you the question, I'll hunt for it here. It says they give you a list here to choose from, and I'll just show it to you here. The psychology test score is relatively better because its z-score is greater, right? Because that's more negative, the negative 3, than the economics test score. So this is what a big reason to use z-scores. What if you wanted to compare men's and women's heights? In other words, you want to compare two different things that are going to have two different means. You can do this by standardization of z-scores. So that's pretty cool, right? So I hope you get these z-scores down. Remember, it's always the data value of interest minus the mean divided by the standard deviation. All right, and this is when we're dealing with the population. We'll do some things later if it's a particular sample where we may have to, if we're given a sample size, we do something different as well. But for right now, this is how you find your actual z-score.